I hope you've watched the sequence video before you watch this video, because we're going to build on what we found out there to help us to arrive at series. So what is a series? So a series is the sum of all the terms of a sequence. So we're going to take all those terms we calculated in a sequence and we're just going to sum them together, or in other words, we're going to add them together. Now we're going to introduce a new notation. We're going to use the summation notation, which we call sigma. So it's going to indicate that we are adding up all of these terms. So a finite series is an expression of the form S sub n equals a sub 1 plus a sub 2 plus a sub 3, so on, all the way up to a sub n. So basically you can think of it this way. We're going to have a finite number of terms. Finite meaning like 1, 10, 20, a certain number, not infinite. And what we're going to do is we're going to figure out each one of those terms, okay, calculate each one of those using the form, and then add them all together. Now it's going to have a different format, so we're going to use that summation notation, and it's almost going to be like, if you compare it to programming, it's going to be like a loop, okay, where you start with I equals 1, and then you go up to n. So the first round it's 1, then you add 1 it's 2, then you add 1 it's 3, 4, 5, 6, 7. And then you do whatever formula is here. Okay? And then you add up all those terms. That's essentially what you're doing. Now, on the other hand, we do have an infinite series. Goes on forever. And an infinite series will have S sub infinity. And you can see the terms go on forever. There's a dot, 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 meaning they keep on going forever. Now you may be asking me, Alicia, I can't calculate things forever. It's not possible. So how am I going to add together all these terms? Well, when we have an infinite series, you are kind of restricted in the sense of if it's convergent or divergent, which we talked about in the previous video. So if you have an infinite series that's convergent, meaning that it comes to one value, you can actually calculate the value of that infinite series. However, if you have a divergent series, which keeps on going to infinity, you're not going to actually be able to come to an answer. So you would just simply be like, it's infinity. It keeps getting larger and larger and larger. So there's no limit to a divergent sequence. And you can also tell that it's infinite because the number on top will be infinity, meaning that it's going to cycle through infinite number of times. Okay, so that might be a little new to you, so we're going to go ahead and walk through an example. Now this is a finite sequence. How do I know that it's finite? Well, I see that it starts at 1 and then it goes to 6. So we're finding the series my notepad wasn't turned on. Okay. So we're finding the series S, losing my pen here, S sub 6, which means we're going to find the first 6 terms of this series and then add it together. So S sub 1 plus S sub 2, A sub 1 plus A sub 2 plus A sub 3 plus A sub 4, all the way up to A sub 6, because it says I go from 1 to 6. So we need to plug in my number in for I. So 3 times 1 is 3, minus 2 is 1. A sub 2, I'm going to plug in 2 for I. 3 times 2 is 6, minus 2 is 4. Okay, A sub 3, 3 times 3 is 9, minus 2 is 7. 4, 12, minus 2 is 10. A sub 5, 15 minus 2 is 13. A sub 6, 18 minus 2, 15, 16. Just kidding. That's 16. You can also see that it increases by 3 each time because you're doing a multiple of 3. So that's another way to look at it, right? You're just finding that pattern of what's happening in that sequence. So to make it a series, we got to go ahead and add that all together. So S sub 6, I'm going to grab my calculator and just so I don't make any mistakes, hopefully. That's the worst when I have no one here to double check me. Okay, S sub 6 is 51. So that means that it sums up to 51. The first 6 terms sum up to 51. So that was a finite series. Finite. Okay. And there is a way to calculate it in Wolfram Alpha if you're not familiar with it. So if you go to Wolfram Alpha, in the box, you can just do series, type in the rule for that series. Here was 3i minus 2. And then you just translate your summation. So from I equals 1 to 6. Now in your homework, you have to show me this work. So you can't exactly cheat and just go to Wolfram Alpha because that's not showing work. So you have to sum up, find the first 6 terms and then sum it up. But you can check yourself because, as I said earlier, it kind of sucks to not have anybody to check. But I can go to Wolfram and go, okay, did I do this right? Am I on the right track? I want to end with an A. That's my goal for this class. So I want to make sure I did it right. Type this in. And then they do give like a little graph here, but you can see sums to 51. So yay, we did it correctly. Who doesn't love a good check? I always love a good check. Okay. So what about if we look at the other way, which is an infinite series? So an infinite series doesn't have that upper limit. So you can see here it's infinite because the top number is infinity. And we need to evaluate it. Well, how are we going to do that? The first thing we need to do is decide, is it convergent or divergent? AK, do the numbers get closer to one value or do they keep getting larger? Well, it looks here, if we do a few terms, sorry, just want to check. If we do a few terms, we'll see that, so the first term would be 2 times 1/3 or 2/3, right? The second would be 2 times 1/3 squared. So that would be 2 times 1/9, which is 2/9. Okay, so it's getting smaller. It went from 2/3 to 2/9. And let's do another one. 2 times 1/3 to the third. 2 times 1/9. Just kidding, it's 27. I was just testing you guys. So this would be 2 over 27. 2 times 1/3 to the 4th. What's 3 to the 4th? 81. Oh, duh. Of course it is. Can you tell it's Friday? I'm ready for a nap. Yes. It's almost vacation, guys. Okay. So you can see that the numbers are getting smaller and smaller and smaller. In fact, they will be converging. We could go ahead and plug it into Geogebra to see where it converges to. So if we kept that and just went ahead and pulled up Geogebra, pretty quickly we can just type it in to see, does this graph converge? Probably the easiest thing to do. So our graph is 2 times 1/3 to the n, which we can just type in as f of x equals 2 times 1/3 to the x. Just use x instead of n. I mean, that's all we're doing here. Press enter, and you can see it does converge to 0, right? Okay, it gets closer and closer to that asymptote, so it does converge, so we know there will be a number. That means we can go ahead and just add these numbers together and see where we're getting closer to. So this would be S infinity, the sum of to infinity. And we can just go ahead and start adding these numbers together. 2/9 plus 2 over 27 plus 2 over 81. Let's go ahead and throw in another one real quick. 2 over 3 to the 5th, 243. We could throw in another one, but just for the sake, I'm going to go ahead and add these together. So it looks like it's 0.99588, blah, 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 blah. And as we increase those numbers, so we could add on another number. So we could add on 2 over 3 to the 6th, 729. So 0.99588477737, add on 2 divided by 729. Yeah, it's 0.9986. So what is it getting closer to? What is it getting closer to? It's getting closer and closer to 1. So it's adding up to 1. Even though it converges to 0, that just tells you that what it converges to, like it's getting closer and closer to 0. But the summation is what are all of the values adding up and getting closer and closer to. The more numbers you do, the closer. It's like adding like a molecule of just a minute amount each time. So it's not going to change it that much each time you increase. So give it a good like 5 or 6 terms that you're adding together to get a good realm. And if you want to make sure that you're doing it correctly, again, you can use Wolfram Alpha. So be careful though, because series, this one's a little bit different because the 2 is not being affected by that n. Okay, so it needs to be outside of the n. So 2 times only the 1/3 is being raised to the n from 1 to infinity, and you see that it does sum to 1. So again, you have to show me your work, but this is a good checking tool. I'm happy to have you guys check your work to make sure you're doing it right and be confident, especially since we have the final this week as well. Okay, and you can see by the geometric series test, the series converges. So, okay, so will the following series converge? So one way to actually do this is to type it into Geogebra. So let's delete our old function and just type in our new one. So f of x equals 10 to the negative x. And you can see here, yes, it does converge. It gets closer and closer to 0 as you go to the right. All we care about are the positive numbers, because remember, k can't be negative. It's positive 1 to infinity. So this does converge. So this will have an answer. I'm just trying to show you that as long as it converges, you will have a solution. Just write out some of those answers and then add it together to see what it converges to. And then once you've done that, just double check yourself using Wolfram Alpha to reassure yourself. Okay, so that is series. Hopefully you enjoyed that a little bit. It's kind of fun to find those patterns. Just keep in mind, is it convergent or divergent? If it's divergent, it's just infinity automatically. Okay, good luck, and I will see you in a little bit to talk about probability.